So, a lot of times we get asked, where do harmonics come from? What are the sources of harmonic currents? Let's take a look at these two waveforms and see what we would call a linear load on the left and a nonlinear load on the right. That's the waveforms from harmonic producing type loads. So, if we look at where do harmonics come from, it feels like it's pretty complicated. We always think of very detailed kind of explanations, but it's really not that complicated. If we just focus on Ohm's law, voltage equals current times impedance, it's really easy to truly understand where harmonics come from. And if we take that one step further and we say voltage distortion equals current distortion times harmonic impedance, you'll see what I mean. So now, if we have, let's say, a facility that has only linear loads, like we saw in the first graph, so we have motors that are across the line. One day we decide we're going to put in some variable frequency drives to make our system more efficient. Now we add current distortion, because current distortion comes from the loads. We say that the harmonic loads produce current and push it back up through the power system. Now, as we add current distortion, you can see that if you add current distortion, you're going to add, the more current distortion you add, the more you're going to distort your voltage. So the more you distort your voltage, the more you might have misoperation and other problems. The more you distort your current, the more you might have heating and issues around that. Now, as we add, let's say, instead of running on the utility system, which is coming through a transformer that has, 5 or 6% impedance, we switch over to a generator because we have backup power, in case we have an emergency. If we do that, the source impedance is going to change. So that's our harmonic impedance, looking back into the power system. If that impedance on a generator is 18%, it's at least 3 times what it is on a normal source. So what happens is, for the same amount of harmonic current, we get a lot more voltage distortion. And you can see, you'd have proportionally, again, it's just a simple equation, we have 3 times the amount of voltage distortion based on the current distortion that's the same if the harmonic impedance increases by 3 times. So, in the case of what came first, the chicken or the egg, in this case, we say harmonic currents cause harmonic voltage distortion. And that current can increase the voltage distortion based on adding more of that same current, or if the system impedance increases, like we said with the generator. So, as we look at power systems, we could have voltage issues for harmonics, we could have current harmonic issues, we could have harmonic impedance issues. And it really depends on your system to really understand what the problems might be. Now, where do those harmonics come from? We said they come from the loads. What are some of the typical loads that we see that produce harmonic currents? It's going to be things like anything basically that's a rectifier, so variable frequency drives or computer power supplies or things that change frequency from AC to another frequency AC. It's going to be things like arcing type loads, and we used to think about fluorescent lights. We think of arc furnaces, things like that. Some rotating machines can produce harmonics, but for the most part today we think about computers, variable frequency drives, LED lighting, and those type of things. So as we think about harmonics, we have to again consider the harmonics come from the current and cause voltage distortion depending on our impedance.